Well, hello friends, welcome back to browser hacking. Today we're going to start looking at auto-generating a bunch of code for the JavaScript bindings in the Serenity browser. So currently we have a small set of JavaScript APIs exposed to the web so that we can do fancy things like draw little rectangles on a canvas and stuff like that. But whenever we want to expose API to the web, we always have to go through all of these steps to manually implement JavaScript bindings for each and every function call. And for example, the canvas stuff that we just looked at, parts of that are in the canvas element wrapper, which is the JavaScript wrapper around a C++ canvas object. And then you basically use the canvas to go and fetch a wrapper for a different object, which is the Canvas Rendering Context 2D wrapper. And all of these types of things are essentially a whole bunch of handwritten, very, very repetitive API wrappers. So here's one, for example, for the stroke rect API, which just looks at the argument count and figures out if we should throw some exception and eventually converts all of the arguments to the right type for C++ and then calls the C++ implementation of the wrapped API. And we have a ton of these files that basically just convert arguments to C++ and convert return values to JavaScript. And I want to get to a place where all of this code is generated so that adding a new web API and exposing it to JavaScript, it's just a matter of adding a single line to a like an interface description file. So that's what we're going to start on today. Now, web APIs are typically defined in IDL, which is the interface description language or interface definition language. And it has this big spec called WebIDL, but we're going to start with a very bare bones, slimmed down version of IDL today. And then, once we have bigger needs, we can upgrade to a proper IDL parser. But I think today we'll just make like a really ad hoc simplified one for a simplified version of IDL. But we'll still start a library for it just because libraries. And let's see. Lib. Let's just copy somebody's makefile. So we'll copy the one from lib. Why not the one from libjs? So actually, let me type out a simple IDL file so we can see what it looks like. So for example, let's take the JavaScript DOM node, which currently is implemented by this node wrapper. Every DOM node that you interface with in JavaScript is some kind of node wrapper. And node wrapper has a bunch of subclasses and so on. And they each add whatever appropriate functionality. But here we can see how the node name API is added to all node wrappers. It's just a put that we do when we construct a new node wrapper. So we're going to do something kind of similar, but we're going to make the code generator produce all of this code, not just similarly, but almost exactly the same. Which is, I guess, what similar means. But anyway, the important part is we want to express this thing through IDL. So let me just get started. So we'll have a node IDL, which will have something like this. So interface node, which inherits from event target. As we can see, node inherits from event target. And then we'll just want to have a read-only attribute DOM string node name. And that we want that to essentially be, in this case, it's actually writing it out as a not even as a constant to the node, but I think we want it to be an attribute that has a getter. We'll see. We're not going to worry too much about being correct about everything. The important part is code generation, because once we generate all this stuff, it becomes so much easier to tweak what happens for any given construct. So then we'll also make the event target IDL. So let's go look at that wrapper. So it has the add event listener function. So let's see, interface event target. I don't think it has a base class. Read-only attribute. No, that's not an attribute. That's it's a void add event listener, and then oh man, what are the APIs like the DOM string event name and oh man, okay, I have to look these up. I don't remember. I guess we can look at our implementation to see what we take, but it's the event name and an event listener. But let's you know, look at this back. What WG? Oops, I just wanted to put that here somewhere. So interface event target. Yeah, so this is obviously they're using more features of IDL. We're not gonna mess with them right now. We'll just do a very, very simple version. So event listener callback. So I assume the question mark means that it can be null, or what does that mean? Question. Oh, we should look in the web IDL for that, obviously. Question. Oh, dang it! I was supposed to follow that. Question mark. Nullable types. Okay, so yeah, so the question mark at the end of a type just means that it also allows null. So in C++ terminology, that would be a regular, like a pointer rather than a reference, right? So I think we'll just add the API like this. We don't do any more fancy stuff. In fact, if we look here, our implementation does not even allow null right now. So maybe we will not allow null, or let's allow null. And then we have to adjust our implementation accordingly. So that's event target and node. And I guess we could also do document, because that one has a few more APIs. So these are the three APIs we've implemented on document so far. So that would be interface document, which is a node, and it has element, get element by ID, DOM string ID, and then we have element query selector, selectors, and finally I guess it would return an array in our case, because we don't have node list yet. It's actually supposed to return a node list, but we don't have a node list type, so we'll just use an array. So query selector all DOM string selectors. Okay, so these will be our 3 IDL files for today, and let's see if we can get to a point where we're generating all of this gunk. That would be awesome. So what's going to happen in practice here, just to think about it for a moment. So for something like this, like obviously this doesn't have the same naming scheme as the Serenity coding style. So the implementation of this function would be called node name. But that's probably okay. So we could have like an implicit, well, like a contract here that for any attribute, for example, then the corresponding C++ object would have an API with, you know, Serenity style snake case name, but with this name that returns a compatible type. So in our case, we would have like string node node name. And this would, and we would generate a getter for this thing that just calls this thing. And I think that will basically work. So let's go for that. All right. So now to make a parser for this business. So we'll want to have some kind of interface object, I guess. So we'll call that interface, or yeah. Do we need for this stuff? libidl, maybe needs libcore. We'll probably use libcore, but not much else. Okay. Although now that I think about it, we're going to want to run this on the host, not on the not inside Serenity, at least not to start with. So maybe I should calm down a little bit with making a library, and we'll just make a code generator instead, because we already have 2 code generators for some CSS related stuff, and we can add another one for this. So add executable, generate JS wrapper, let's say wrapper H. So we have one program that creates a header file and one that creates a CPP file. It's a little bit of a weird setup, but maybe we should have, it could just run it in 2 modes, or it could spit out both files. I don't know what's the best solution. Maybe we'll make a single program for this. I don't know why I did the CSS stuff as 2 separate programs. It's kind of annoying, actually. So we call it generate JS wrapper, or maybe wrapper generator is better. Yeah. And then let's not get carried away with making a library right now, since everything is so up in the air anyway. Okay, touch wrapper generator. Okay, so let's make something that can read these things. What's the most important thing? A copyright header, obviously. Okay, second most important thing, to include something. Main something. Let's get args parser, and let's make an args parser. Add positional argument. Path. IDL file. I don't know. I never remember which one is which out of these. Okay. There we go. And then all we have to do is just load this file. So file, core file, open, path, core IO device, read only. Okay. Data? I don't know, something. Read all. Okay, let's get all the data. And then let's just throw all the data into a byte buffer. And then we want to throw it into a parser, and then we want the parser to give us some stuff. So we want it to give us struct interface. So one of these things, and what's a struct interface going to be? Let's see, always on top. We can do that. All right, so struct interface, it has a name, and it has a parent name, I guess. It's the parent interface, or the base class, if you will. And then it has a vector of members, I guess. So what is a member? A member is actually, maybe we should separate, probably separate attributes and functions, I'm thinking, because on node IDL we have an attribute which has to be handled a little bit differently. So let's say function, or function, you know what, let's do it this way. Okay, so the function has a name. This is one of these guys, and it has a return type, and it has a, or we can even say a type. And what is a type? A type is a name and a nullable flag. Okay, so the function has a return type, a name, and then it has a set of parameters. So a vector of parameters. Okay, and what is a parameter? Parameter is, to start with, it's a type and a name. Okay, and that's essentially everything we need to describe everything what's in this file. And then we'll need to define an attribute as well. So an attribute, we'll change this here to say function attributes. Okay, so attribute will be a read-only flag, and then it will be like a type, and it will have a name. So I think we can just start with that. That's pretty good. And then, of course, we're going to need to add a lot more stuff here eventually, but this, if we can turn this into one of these, that would be a great start. And then obviously, because these things like point to each other, I'm wondering, do we have to like read all of these things? But maybe we don't. I was thinking, like, do we need to load all the files into memory? It's probably not necessary right now. It will become necessary later when we add mix-in support, but right now this will probably be good enough to just load one file at a time. So let's see if we can parse one of these. So we'll just see that we are reading it correctly by compiling this. Okay, and then libraries, libweb, code generators, wrapper generator, and then we will give it an IDL file. So libweb dom node IDL. Okay, so we can see here that it can actually read the file. Great. Now there's nothing stopping us from success. So let's see. vector interface. Or maybe we should even do something, or I'm just thinking, what should the parser API be? It can be something like this, Parse Interface. String view, string or input. Here we go. Okay, so interface is IDL parse interface data. If not interface, cannot parse this file. Sorry about that. Like, this doesn't have to give nice error messages or anything, because this is something that we're going to do at compile time, basically, when we're building the operating system, right? Or when we're building the browser. So it's not important to have like a good user experience for this, other than like a good to me or good to whoever's using it to add functionality. But yeah, so I guess we'll start here by just making an interface object, which we will return at the end. But if something goes wrong, we can just return null, and that will be a parse failure. Okay, and then t-index 0, while index is less than input length. Okay, and let's do the good old peek and consume pattern. So peek, peek with an offset. So return, or no, if index plus offset is greater than input length, return 0. Else return input index plus offset. Right. Okay. So now this will be context free, so we'll just look at I don't know. Actually, let's not overthink this. Let's just go. So when we're starting, we are looking for an interface. So we'll say parse interface. Oh, that's where we are right now. So what we should do is look for the name interface here. So name. I'm going to consume the string interface space. Consume string. Wow, I haven't written one of these goofy parsers in a while. I forgot how I normally do it. Okay, so assert consume equal to string I. Yes. Yeah, that's pretty good. Okay, and then we want to consume a name of the interface, I guess. So consume while do it this way, interface name, consume while. So while the input character here is not a space, so consume while will be something like call it the condition. While condition consume. Wait, what's wrong with that? Oh, right, I have to actually call it. Peak. Okay. Wow, I feel so rusty somehow. Right, so this is going to return some kind of a string. So what we'll do is we'll make a string builder. And builder append what we consume. And in the end, we'll return builder to string. Right. All right. So then what we have next is space, colon, space. So let's just be extremely specific about the thing we expect here. Or rather, actually, this is optional, right? Because our event target IDL does not have a base class. So now we'll have to consume potentially a base class. So here we'll say consume white space, which will be while is space peak consume. Okay. All right. Consume white space. Fine. We'll be a little bit more lenient, I guess. So now, if peak says colon, then there will be a base class coming. So we'll consume white space, and then interface parent name is consume until we hit a white space character, and then consume more white space, and then we should consume a specific character and fail otherwise. So assert that consume gives us the expected character. Okay, so consume specific. We want an open curly. All right, and then consume white space. So now we go into the loop here. So basically, this will be the loop until the end of the program, and then we'll return the interface. Okay. So what does this loop look like? We look for read only. So if peak, I guess we can peak for a string, read only. Then consume string read only. Next is okay. So So if next is read-only, consume it, and then we say what's coming up is going to be an attribute probably, but we don't know that yet because read-only comes before the text attribute. So we can say read-only false, and then if it says read-only, we'll say read-only true. Consume white space. If next is attribute, parse attribute. Can we do that like this? I guess if we see read-only, we can parse attribute. Next is read-only or next is attribute. Let's do it this way. Yeah. Otherwise, let's say if peak is end curly, that's the end of the loop, like that. Otherwise, we'll have to take it as a function. So parse function. So on this, we should actually break. All right. And then when we return from this guy, we should also print it out. So for auto interface attributes. Read only and name. Nullable is attribute type nullable. Okay. So that's pretty good. So then we'll just log like attributes like that. Functions, and we'll do almost the same thing, but for functions. Return type, all right, and function name. All right, we'll add more to this as we go, but don't have to get too fancy right now. So how do we parse attribute and how do we parse function? Attribute we parse by doing if next is read-only, consume string read-only, read-only is true, consume white space. Okay. Then if next is attribute, then we just consume it because we already know that this is an attribute, so it's not really interesting to us. And then comes the type of the attribute, which will be, I guess we can put that in a helper. So parse type, or auto type is parse type, and then interface attributes append, And an attribute, what was the order of things? It was read-only type name, right? So read-only type and name. The way we got the name was consume until whitespace. I guess we should say until whitespace or semicolon. Yeah. Okay. And then how do we parse a type? So the name will be, again, parse until we hit a whitespace character or a question mark. So if peak is question mark, then nullable is true, so we can actually write it like auto nullable, like that. Okay, and then return type name nullable. Okay, that's pretty good. So then we only have the function left, so parse function will be kind of similar. So we'll start by parsing the return type. And then maybe at the end of parse type we should be friendly and do a consume whitespace, because why not? Or we can also do that after calling it. Okay, so consume whitespace, and then what comes next is the name of the API. So like this, space or open paren has to be the thing we look for. Okay, and then consume specific, and we wait for the open paren. Okay, and then we have like a type followed by a name followed by a comma or a close paren. So it's the parameter loop. Vector parameter. Okay, and then type is parse type. Consume whitespace. Then the name is this, but then either it can be followed by a comma. Or wait, what am I doing? I want to stop in these cases, not continue. Okay. So if peak is a comma, then we'll continue. Do another one. But if it's a close paren, actually, yeah, if it's a close paren, then we should stop. So we should break, otherwise, consume specific, we should expect to find a comma. Okay, and then we'll do consume whitespace and keep looping. And then we also need to add it to the parameters. So append parameter type name, something like that. Okay. Return function, return type, and name and mode parameters. Okay, did I do that right? Almost. And we have a crash. Great. On line 82, so we're crashing in consume specific. That's fine. So let's see, let's print out something that helps us here. So if this is not that, assert not reached, and then we'll say expected ch consumed at byte at offset but got, and then what we actually consumed at that offset, and then we can figure out what's bad. So at offset 82 we expected a comma, but we got a space. So it's right here. We got a space after this event listener. All right, so I guess it would be good to see a call stack here. What's the easiest way to do that? Maybe just val grind. Okay, so we're not seeing it. We're not seeing the line number. We're in Parse Interface, and then one of the lambdas. How do we get line numbers? Oh man, I don't know how to turn on line numbers for like one, or debug symbols for like one program. Wrapper generator. I guess I could turn it on for everybody. It's very hackish. But let's just do it. Do I have to rebuild everything? Oh my goodness. Okay. So let's think about what was going wrong in the meantime. That we ended up, was this the only file that it was not trying to parse? So we're sitting after the question mark here. So that would presumably be in parse type if everything else is right. So I guess we're not consuming the nullable question mark. If nullable, then consume specific. Oh wow, this is going really slow. I don't even want to rebuild that if it's going to be that slow. So we'll just assume that that was the mistake and see if that corrected it. So wrapper generator. Okay, well now we're at offset 96 instead. So what did I mess up there? At the very end. Okay. So you expected a open paren, but instead you got new line. You expected an open paren. Consume while should probably fail if we run out of input, for one thing. Otherwise that gets a little weird. but why are you expecting that at 96? So let's see. What do we have in this file? We just have one API, okay. Parse function. Parsed a function. Yeah, we parsed the function, that's great. And then what? Consume white space. Well, that's what we'll do up here anyway. We parse the function, and then what comes next? Should be a new line, I would think, but let's see if we're in some stupid nonsense. Next is the close paren. Oh, because parse function doesn't consume the close paren. All right. Consume specific, close paren. And let's even consume even more specifically the semicolon. Okay, so now we got through all the way, but it didn't append anything. It just parsed a function, but didn't add it to the functions. So interface functions append something like that. I don't know. Okay. It's a non-nullable add event listener, non-nullable void. Fine. We should probably dump out the parameters as well. For auto parameter in function parameters. And this is a pretty ad hoc parser right here, but I think it will be good enough for our needs. I often tell people to, like, don't be afraid to make crappy things on your way to making great things. And I think this is like me showing you the process of me building something crappy that will eventually replace with something better, because it's an iterative process. Okay. Here we go. So this is our function. This is a really awkward output format, actually. Maybe we can do this in a much nicer way. So we can just say return type equal, and if it's nullable, we can actually just add a question mark, because why not? Makes it so much easier to understand what's going on here. If attribute read only, then okay, I'm not even sure what I'm doing right now. I'm just tweaking the way we show the debug output for some reason. This doesn't have to say type. Why does this seem so important right now to format everything nicely? It's clearly not particularly important, actually. Yet I'm still doing it. No, we'll do it like that, and then we'll indent the parameters. Yeah, that'll be good. Oops, what am I doing? Oh, we're forgetting the parameter name. So maybe this should have been like this, rather. Okay, finally. This seems vaguely understandable, so now we have something that can parse this thing. Let's try it on another class. Node IDL fails because Node has... What does Node have? Node has this guy right here, and he has a parent as well. So it fails for the parent, expected a curly brace, but instead got a capital E. Oh, right, because we have to consume the colon. I wonder, you could have an API like this, like if consume if. I'm going to use this opportunity to play around with things. So consume if would be if peak CA peak is CH, then consume, return true, otherwise return false. That's kind of a curious way of expressing that. Consume if. So same thing here, really. Like if consume if, because then we don't have to grab him there. Likewise with this guy. Interesting. Okay, so now at offset 78, we expected an open paren, which is at the very end of the file. Okay, so event target works fine. Document works fine. Space missing here. Okay. Very important debug formatting here. And then why didn't you like node still? At the end of the file we're expecting an open paren. I guess it starts trying to parse a function for some reason. Wonder if it ever parses an attribute in the first place. parsed an attribute. Okay. So do we not parse the semicolon at the end of the attribute, I bet? Consume x specific, like that. All right. We are home free. Great. Well, that was a lot of hacking around. Now let's actually do something interesting with this thing that we have constructed ourselves. So what we want to do is we want to build, let's start with a header file. So say that we're doing event target, right? Event target wrapper. So we want to construct this header file right here from the input that we just got. So let's just start it and see what happens. So we'll get rid of this editor, and maybe we will, actually let's leave this open here. Okay, so wrapper generator, and we'll just start printing out stuff. So if mode is, or let's say right header, generate header. Just so we separated it into its own function for header and implementation. Generate header. Something like that. And basically we just want to create this file that we have right here. So the one up top. So we'll just start. Here's an opportunity to skip the copyright header. So let's see, wrapper.h, and then this stuff we can kind of just copy down, I guess. So like, it's nice to have nice looking output. Like, it doesn't have to be perfectly looking, but it can be sort of nice looking because we're gonna have to look at the output to understand it later. So, okay, so here, class, interface name, wrapper. And it will be a public interface, we'll call it the base class name. Okay, so that's how we'll start it, and then we'll have to work out what the base class is. So base class is a string. So if the interface parent name is empty, then the base class is wrapper. So that's the wrapper class here is sort of, if you don't have a base class, then you have to inherit from wrapper still. But otherwise, if you do have a base class, then the interface parent name actually is the base class. So in fact, we don't even need to do this because we can just do parent name wrapper like that. That's nice and easy. So let's see what it would look like for event target so far. Okay, yeah, so this is the output. And we can even disable this stuff for now so that we only get the output that we care about. Okay, so we're off to a start. And then we want to put out a couple of things, so like a constructor, constructor declaration, destructor, and so on. So interface name, global object, and here we want the I guess we can make a little shorthand for this. So like wrapper class name is like that, and base class name can be, yeah, makes this maybe a little bit nicer if we can just write things this way. Wrapper base class name. All right. Because here we're actually going to pass in a reference to the C++ object, and the C++ objects, they always have the same name except with no wrapper at the end. So this is kind of easy. We just pass in the interface name and an ampersand for a reference. And then we need, this one is standard, same in all implementations. Okay, and then we also need a destructor. Wrapper class. Okay, and then let's add some helpers to get the C++ object. So that will be interface name, amp impl, something like that, and the const variant as well. Okay. We might want to add a cast to that one later, but for now this is okay. And then we'll need some private stuff. So class name implementation. Wrapper class. Actually, let's stop calling it this and let's just emit the C++ object name instead. That would look nicer. Okay. And then come all of our functions that we have. So interface functions. JS declare native function. Snake. So we'll do function snake case name, or snake name. So now we have to convert the web style API to a snake case name. I'm not exactly sure how we're going to do that, but how hard can it be? And then for attributes, I guess we'll add a native getter. And setter, if it's not read-only. So if attribute read-only, if not read-only, we add a setter. Okay. So what do we get so far? Compiler error, because I didn't come up with the snake name thing. Right, so we'll actually do it, we'll make it into a function instead. Snake name. Okay, and then static string snake name. String view camel name. This is like the one time when camel name makes sense, but even so, we're gonna snake name it here. because that's the rules. So, I guess we'll just do this like if is upper ch builder append an underscore builder append to lower ch else builder append ch, something like that. Okay, so there's that thing. Seems to work fine. We'll need some semicolons here. But basically it's essentially crapping out the event target wrapper class as we want it to look. That's great. Super great. So let's do node wrapper, see if we can make it dump that one out. Of course, currently it doesn't actually have node name as an attribute, and let me just verify that I'm doing that correctly, because I think it's supposed to be an attribute, but now I'm not sure. So read-only attribute DOM string node name. Okay, yeah, so that's fine. Then we're gonna have to change it to be an attribute instead, but that's okay. So I guess let's instead look at the document wrapper. So what would it look like if we crapped out the document IDL? So it inherits from node wrapper, has these things right here. Of course, they're called node here for some reason, but we'll just call them impl everywhere. C++ object will always be called impl. That's fine. And then we have these three guys as native functions. So I think that's essentially pretty good. I like it. So let's see if we can generate an implementation file as well. So generate implementation. And I guess for now we'll just make him be quiet. But for the implementation, oot. So what goes in the document wrapper CPP file? It's a whole bunch of stuff. So I think we'll pull in, like knowing which headers to pull in, that's going to be kind of tricky. So we'll start by just pulling in stuff that seems useful. I think like the very basics of libweb and libjs, like the interpreter, fly strings, JS values, stuff like that. And then we can also pull in the header, of course, that we've generated for this particular thing. So this is going to go in libweb bindings, wrapper interface, the wrapper name, wrapper class, wrapper base class. I guess we can add some stuff like that to interface. Added for convenience after parsing. Wrapper class, wrapper base class. And then at the end, where do we return interface? Here. Okay, and then we don't have to do this here anymore. Well, we can also do it like this. All right, I don't know why I'm fidgeting so much with this stuff. Let's just say like that. Okay, so what do we have to start with? We will do namespace web. Namespace bindings. And this one also has namespace twice. So we need one class close and two namespace closes. Okay. So wrapper class, colon, wrapper class. Here comes the constructor. So it has a global object, and the interface name impl. I guess we can call that. 1, 2, 3, 4. Wrapper base class. Pass this stuff to the base. Wait, node wrapper takes that. And then what does node wrapper do? Takes the event target wrapper, okay. What does he do? Some other stuff. Well, that's probably fine. Okay. Document wrapper. So then we'll just do, I mean, this file is really simple. So constructor. We can write out little markers like this so we can tell what's what. And then like this. And a curly and a closey curly. Okay, and then we call the base. Initialize. This allows the base class wrapper to add whatever functionality he wants. So like first you add stuff from the base class. So if you're a document, the node, which is the base class of document, will add his stuff first. So like node will add node name, node type, and so on, and then document will come and add his functionality. That's why we have to call it the base here. Okay, and then we have to do a bunch of define native functions. So interface functions, define native function, snake name, function name. And then comes like the length. So I'm a little bit confused about how we're going to compute the length for these things. My understanding is that it's supposed to be the number of mandatory arguments. So that's what we'll do right now, and then if I'm wrong about that, then we can fix it later. So like that. And actually, we didn't want this nickname first. We wanted this nickname after. First, we wanted the regular name, the web name, and then we want the snake name. And then we want the function.length, followed by a close paren thingy. Okay. And then how do we compute the function length. I guess the function length, maybe we'll make a helper for that here. Fix me take optional arguments into account. Right now we don't have any optional arguments, so we don't have to worry about that. Okay. Okay, so we have the document wrapper class here starting to fill out. Of course, the destructor is very empty, so that's easy to add. Okay. So we'll just do like that. And boom, we have the destructor as well. And then we want the, some impl functions, I guess, because the impls might be out of line. Maybe we should put those out of line always. Or I'm not sure. We'll figure that out later. It's not going to be possible to generate every single interface, I think, but many of them we can generate. It might be that we end up not generating the base interface, so the event target interface. Maybe we'll leave that one hand-coded for now. I don't know. We'll go one step at a time. So now let's generate one of these, an impl from. So impl from is, we have this in every single wrapper. And basically what it does is that it takes a look at the interpreter and looks at what is the current this value in JavaScript, and then it tries to convert that into a document wrapper in this case. And if that is successful, then it will extract the underlying C++ document object from the document wrapper. So we'll make one of those. Static interface name. Impl from JS interpreter JS global object. Okay. So how is this guy gonna work? Well, we're just gonna take the stuff that's up here and make sure that we print out the same stuff, I guess. Because like I was saying earlier, all this stuff is really repetitive, so this is the whole point of the generating it, is that to stop writing super repetitive code. It's going to be very, very nice. And this will allow us to add much more functionality much faster without having to worry about making stupid little mistakes like typos and stuff. And whenever we want to tweak something about how bindings work, we just have to edit the wrapper generator. So, string view. So this is where we're comparing, checking if the class name of this object is the same as the current this value. So that would be, what am I looking for? The wrapper class? No, the interface name. Okay, and then we have to throw. If it's the wrong type, then we gotta throw. Not a. Okay. By the way, we're skipping over one big thing here, which is constructors and prototypes. In this first version of this, we're not going to bother with those. That'll be stuff that we add later as this matures. Okay, actually we can say return null putter here. Impl. Okay. So I think that's our impl from function. Here's one for document, beautifully generated. And can we make the same one for node? Yes, we can. Beautiful. Okay, and then come the various functions. So this is the tricky part, right? So now we actually have to generate implementations of these APIs. Functions. Define native function wrap class : snake name function name. Okay, here they come. So first we get the impl from interpreter global object. And if that fails, actually, yeah, if that fails, return an empty value. Okay, and then we have to check. Now comes this part where we have to check for argument counts and stuff. This will be a little bit messy, but I guess right now we can just say that we have the wrong number of arguments if we don't have the exact number that we want. So how would we do that? If interpreter argument count is less than function length, return interpreter throw exception JS type error. And what kind of arg count needs oh, how many arguments do we need? We can do that one. Add arg count many. And then the name of the API, so that would be the function name. And then we also need a stringified version of the number of arguments that we expect. I don't know why that's a string in this case, but we're just going to roll with it. Does that actually make sense? Oh, it says 2 here. Seems like we could just use a number, no? Yeah. Well, let's not overthink it. Let's just give a string. So after that, we do that, and that, and that. Okay. So let's bring up document here. Okay, so far so good. Here we'll say like, oh, I don't have the right number of arguments. This thing should have quotes around it. Okay, looking very good. And then after that comes, now we have to convert each argument to an appropriate C++ type so that we can hand it to the function that we're calling. So let's see, parameter in function parameters. So what kind of parameters are we working with in this test here? In our case, these are all DOM string. So let's have like a little mapping function that just maps from an IDL type to a C++ type that we can handle. So CXX type, or a web type for IDL type. IDL type. If IDL type is the same as DOM string, return string. And if we don't have some conversion that we want to make, then just use the original type name. Okay, so now what we'll do is actually, this needs to work differently depending on the type here anyway. So let's see. If parameter type is DOM string, then what we need to do is parameter.name. We can even snake case the name to make the code look nice. Equal interpreter dot argument argument index dot to string for interpreter. Okay, and then here we can have something like okay, so how would this look like? Oh, we're not using that thing. Oh yeah, maybe we don't even need it because we have auto. Okay. Yeah, so this looks pretty good. And then we need to do an exception check to see if we threw an exception in JavaScript while converting it to a string. So if interpreter has an exception, then just forget about everything we were doing and leave, because we can't make progress if there are exceptions. Okay, and then after we have pumped out all of the arguments like this, we need to make the actual function call. So if the function return type is void, if the type name is not void, then we need to actually print out the return type. So I guess we'll do something like return value. We need something that doesn't get clobbered, so we'll do some hack like this. Or wait, nobody's gonna have retval as as the parameter name, so let's call it retval. And this is going to be impl, and then the snake name of the function name, and then like this. And then now we have to print out all of the argument names one by one. Do we have some join thing? String builder join. Yeah, right. Argument builder join all of the parameter. Oh wait, how does this work? Okay. Let's get all the parameter names. Let's do that up here while we're extracting them anyway. Because then we can just do a join here. So arguments builder join, comma, parameter names, to string, okay, so there's the thing. Maybe we should even use auto amp. Oh wait, hold on. Let's see. So if it's not void, auto string. Hold on. Because I want to have a different auto string depending on the nullability of the type. So if the function return type nullable, we'll use auto start, otherwise we'll use auto. Yeah, auto is fine. Should we just always do by value here? Maybe I'm overthinking this. We can also just go by value and use auto, and then we can tweak this later if it becomes an issue. But I don't think that it would. Right. And then if the return type is nullable, then we need to do this little thingy-dingy here. Out if not retval. J is null. Okay. Otherwise we may need to return a wrapper. So now this really depends on what we're returning. So let's see if needs wrapper. Function return type. So if the return type needs a wrapper, then we have to, or actually, wrap wrap call, wrap return type. I don't know exactly what I'm trying to do here, because we have to do something different. If you're just returning a string to JavaScript, for example, then we can just return a JS string. But if we have to return a node or an element or something, we have to return a node or element wrapper. So, but maybe this can be logic that goes right here. So if function return type is DOM string, then return JS string, and then retval. Okay. Otherwise, if it's I guess we can just ignore other types for now and just say else. Else we'll just call wrap. So wrap has to pass the heap and a typed pointer to whatever this is. So whatever retval is. Something like that. It's a little bit weird. This will probably need some tweaking. Right, so in this case it's an array that we're producing. So what are we supposed to do with the array? This thing gives us back a vector of element, and then we have to turn them into an array. So this code right here, for example, is already kind of awkward, because basically it's not obvious how to return an array for me, but I guess we could have like a special case that generates an array from a vector. So what would that look like? If we just generate array, we'll call it like array from vector, something like that. This will be our special secret. So if you are doing one of those, function return type name is array from vector as hack once it's no longer needed. Hack fake type hack. Yeah. So for one of these, we'll say we need to do this logic right here. So we need to construct a new array. New array is JS array create with the global object. I guess we'll just call it element in this case. So element in retval. New array indexed properties append Yeah, we'll do something like that, and we'll just expect the C++ type system to make it work. But this will go away. Let me note that here. Basically, once we have a node list, we can throw this out. Yeah. Okay, so now we can produce this file. That's pretty awesome. I guess we should try to plug it into the system. So how do we do that? I guess now we have to edit the build system. So how do we run the code generators now? Codegen, yeah, generate. Okay, so we generate some files here. Let's add some more custom commands then. Add custom command, output, DOM, no, bindings. What do we call this thing? We call it like node wrapper.h. So we need to, like, we're going to do this kind of manually the first time, but then later on, obviously, we want to not have to write tons of lines for every new wrapper in the CMake list either. But right now, I just need to figure out how this works. So, okay, I guess this is necessary if the directory doesn't exist. Wrapper generator, current source dir, DOM node IDL, two bindings, node wrapper h. Okay, so wait, we need two different run modes. So we need the header mode, and we need a we need to add a separate one that creates the CPP. Okay, so this is the header mode. Verbatim, I don't even know what that is, but we'll add it anyway. This depends on wrapper generator. Main dependency is going to be bindings DOM node IDL. Okay, I hope I'm doing this right. Generate depends. Okay, so we should be able to actually just remove the old node wrapper stuff. So we'll just toss it. And okay, so what are we messing up? Can't find node wrapper CPP. Well, that makes sense because I just got rid of it. Oh wait, then I want to build it. So how do I actually build it? Property ID.cpp. Oh. Wait. Cannot find the source file. Okay. But you don't have property ID CPP either, do you? No, you don't. So why is that fine? Property ID.cpp. This guy's here. He doesn't exist. He's generated. Generate property ID CPP. Where do we generate the CPP? Property ID CPP. Generate property. Oh man, I am so not strong with CMake. But then maybe I don't need a custom target for this guy. Oh, wait, I'm stupid. I didn't do anything for the CPP file. Oh. That's why nothing's happening, because I only did the header. Okay, so if we do that, and I need to have unique names for these. Or what's the problem? Yes. Ninja. Okay, yeah. So now we need to actually listen for those command line flags. So, where's main? Here. Header mode. Run in header mode. Generate the .h file. Okay. And then I guess, yeah, well, you know, you have to pick one of them, but right now it doesn't seem like the most important thing in the world. So, what happened here? Now we actually generated something and we're trying to build it. But it doesn't build. But that's certainly something we can deal with. So, can we find this here? This is, yeah, QCreator finds the generated code. That's so cool. So this thing is not here. But that's probably only because my QCreator is not set up to look for it. So how would I do that? Build libraries. That should find libweb bindings node wrapper.h. Oh, wait, what are you doing there of all places? That's an interesting location. I guess we can set that as an include path. Okay, so we want to call event target wrapper, and he doesn't like it. And then you also don't like this one. Oh, because it doesn't know what global object is. We have to include global object. Wrapper generator needs more includes. Okay. Do not save. Okay, so that one is good. What's going on here? Oh, this doesn't look right at all. Wrapper gen string view. Let's look at the header file it made. So, wait, is this the header file that it made? exactly right. It looks too good. Wait, so this CVP file depends on the H file, so we need to make sure that the H file is constructed first. How do we do that? Property id.h. Oh, we added up here as a thingy. Okay, so what if we do that? Does that just make that happen? Oh my goodness. What on earth? It includes itself in the header file. That's pretty stupid. Oh shit, wait, I guess they're both implementation files because I didn't actually do anything with the flag, like if it's a header or implementation mode. That would explain the problem. Okay, so if header mode, if implementation mode, if you specify both, you get both. Doesn't seem very useful, but it's up to you, dude. Okay, so now node wrapper is presumably a little bit sad. Yeah, this doesn't look very good at all. Mostly because of that crappy header include statement. Yeah, what was I even thinking here? So now we can just go here and, wait, that doesn't look right. We can just go here and tweak the header manually and figure out like what more do we need to add. So we need the base class, like event target wrapper, and then we also need, these guys need to call the base class impl and cast to the current class impl. So we can fix that. Do not save. If wrapper base class is not empty, wrapper base class .h. Very cool. And then for the impulse, if we are the base class, then we just return our m-impl, otherwise we will cast. So this will be static cast to interface name. Wrapper base class impl, something like that, and just need a const variant of it. Okay. Cannot bind, oh, because we need the definition. Guess we can include it. DOM interface name. Oh, we can't cast a mutable to a non-mutable to a mutable. That's not going to work. So we need to add const here. Okay, so the node wrapper looks compilable. Here we are missing a return type on this function. So let's add that. Wrapper gen. Initialize needs a void. Okay, and then node. Oh, document wrapper. Now this is getting messed up because of the name change. But we could actually just get rid of document wrapper too, since we're bindings. Goodbye, document wrapper. Goodbye, document wrapper. Okay. Oh, and then of course we need to add it here. Yeah, so let's skip generating event target wrapper today and only do node and document. That would be a good start, I think. Oops. And then I can go and figure out how to do this nicely later. Right now we're just going to make it work. Document. Okay. Document wrapper. So what are we working with now? We have all of these functions that call node. Let's just fix that to call impl for now. Just patch it up a little bit. And image element. Okay. This will go away when we generate these as well. Just try to make it build right now. Okay, and then what are you whining about? Let's go see in document wrapper. Oh. So this is generated, and we have a bug here, missing a paren. And array is incomplete, so return, where do we have the ret vals? This one needed one of those guys. And we also needed JavaScript arrays. Where are we? What is this? Document wrapper 44. Wrap. Oh shit, did I delete the... Did I just get rid of the wrap function for nodes? I feel like maybe I did. Yes, I did. This guy knows how to wrap all the different nodes. And we need to have that function somewhere. So let's maybe put him, let's put him with like, where do we put him? Let's make a separate file that does this for now. So let's say node wrappers, node wrapper factory dot h. Yeah. And then in node wrapper factory.h, we're going to do this gunk. So this guy will know how to create every node. Maybe this won't, maybe this shouldn't be a header file actually. I think maybe we'll just make this a declaration and we'll put the implementation elsewhere, because this thing is going to have to include like every .h file from from the DOM, so it'll be very heavy if we include it from everywhere. So I think we'll just do something like this. And we'll have a bindings node wrapper factory.cpp. Touch bindings node wrapper factory. Okay. So what are we going to do here? We just need to include all the different ones that we need to construct. This should be generated later as well. It's just a different type of thing. This will be we'll have to generate this from like a list of all supported DOM elements or something like that. Something like that. Bindings wrapper. Okay. Now what are we failing? We still don't see wrap because we didn't include it, I guess. Node wrapper factory.h. Okay, this is getting really messy. Like I can't even see what all the errors are. What's the first thing? Incomplete type error. Okay. Let's fix that by just including error. And then impl from is defined but not used. Oh, right, because we never generate the attribute thingies. So what's going on here? Node wrapper factory. Cannot convert a document wrapper to a bindings wrapper. Probably because we lack class declarations. What if we could see all of these fancy boys? Oh man, I'm losing track again. Okay. Wrapping a node amp. Wait, no. I'm trying to create a node amp from web element. What's wrong with that? Is it because you don't know what the DOM thing is? DOM wrapper class. Do you need element for that? Seems like you did. Oh shit, okay. Canvas 2D wrapper. You don't know about canvas element. Wait, what? Oh, because you need to see the factory. Okay, so now it's just a matter of including the factory from some places. Okay, list of problems getting short. Node wrapper has an unused function, and in node CPP we need to see the factory as well. Okay, now we just have this one problem. So wrapper generator needs to be smart enough to do the attributes. We're only doing functions. So these are all the functions, and then maybe we'll do the attributes first, actually, because why not? Implementation, attributos. Actually, maybe they will be quite similar to functions. Let's see. So we'll do the getter first. Attribute name underscore getter. That's what we usually call those. So let's see. Let's look at some existing getter that we have. For example, in the window object, we have a document getter. Okay. Yeah, so it's really just a matter of like doing an impl from and then calling the thing on the impl. Okay. Wait, so that's what we're already doing here. Get the impl and then return. And then it depends on what the return type is and so on. I guess this is exactly the same between functions and attributes, at least for a getter. So we'll do something like generate get call. Or, well, these are a bit different. we don't have arguments and stuff. Okay. Yeah, that's true. So I have to think about this a bit differently. And there's no void type to care about. So it is different. Retval, let's say, because why not, is impl snake name, attribute name, like that. Okay, and then I guess if it's a nullable attribute, is there such a thing as a nullable attribute? Yes, we have right here a nullable attribute, obviously. So if attribute type nullable, then if not retval, return a JavaScript null value. Very cool. All right, and then, oh shit, wait. There we go. And then comes all of these types where we convert the thing. Okay, so generate return statement. These should at least be compatible. So we'll give the return type function. Yeah, we actually only need to pass in the return type. Return statement. Something like this. Generate return statement for attribute type. And then we can simply close up the getter function and we are good. Wouldn't that be cool? Oh, wait. I'm putting function into the output stream somewhere. Where am I doing that? 405. No, oops, doopsie. Oh, we're missing something here, right. Semicolon. Okay, we have actually unironically managed to build. Let's see if it actually runs. It's pretty cool if it does, because then that should allow us to quickly add a whole bunch of APIs. So this thing is working as far as I can tell. It does have various wrappers in it, so that's good. Let's bring up an inspector and quickly, or a console rather, and just quickly talk to document. We can see his functions here. Document, query selector, all. And it seems to be doing stuff. So what happens if we now quickly add a bunch of things to the node? Interface node. So we can add like these guys right here. basically just exposing child pointers, sibling pointers, stuff like that, because we already have these getters already exist in the code. So it should just be a matter of adding them to the IDL. And let's see. Okay, document. I don't see the things from node here. Document, first child, undefined. Okay, so why are these things not showing up? Node wrapper. Wait, did we forget something in document wrapper? We're calling node wrapper initialize. But he doesn't add a bunch of things. Oh, crippity crap. We're forgetting to add attributes. So wrapper generator. Hold on. When we define native functions, we also need to define native properties for all of our attributes. So out. 1, 2, 3, 4. Define native property. And this is a matter of attribute in attributes. So first comes the Webby name. So that's like that. And then comes the, wait, let me see how this is used somewhere. I think we have to specify both a getter and a setter. Yeah, so name, and then the getter function, setter function, and some attributes. We'll just, I think maybe we can just use these, enumerable and configurable, let's say. So we'll use those, yeah. U8 default attributes. Okay. Then here comes the name getter. If it's read-only, then comes null putter. Otherwise, we want the attribute name again, setter name. Setter callback name, setter callback. Yeah. Okay, let's do it this way. Default attributes, okay. So string setter callback name. Wait, where do we parse the attributes? Okay, attribute name is this. This is pretty hackish, but maybe that's okay. Oh, forgot to snake name somewhere. These need to be snake names. And I guess this is too early for snake name because we put it pretty far down in the file. Oops, so we'll just move him up a little bit. Put you right here. Don't even worry about it. Snake name. Oh. Alright, fine. At the very top then. Oops. Document. And now we have some new functionality here. Document.firstChild. Ooh, not a node object. Are you upset about something? Let's see. Document wrapper. This would be a node wrapper. So, oh shit, yeah, right. Because it's not a node object, but it's something that inherits from node. This isn't something that we have faced before, but basically the JavaScript objects, the wrappers, they inherit from one another, right? So we have this check here that you have when you're invoking an attribute getter, then we verify that the thing you're getting the attribute from is a node, but we just do that by looking at the class name. So if you're getting it from a document wrapper, it inherits from node wrapper, but we don't know that here, or at least we don't know that by looking at the class name. So what's the way to solve this? I guess really we would need to have some object chain that's sort of like a meta class object chain so that we can do inheritance lookup. But that's unfortunate. It would be nice also if you could just, well, no, we shouldn't need to do some hack like that. I mean, we have everything in the C++ type system. So let's see. Let's commit what we have already because it's getting a bit huge here. So let's add node. Let's not do the event target. This is a little bit messy, but it's all good. Okay, libweb. Start generating JS wrappers from simplified web IDL. This patch introduces a hackish but functional IDL parser and uses it to generate the JS bindings for node and document. We will see how far this simple parser takes us. I think the important thing right now is generating code, not being a perfect data parser. So that's really cool. So how do we deal with this inheritance problem? What we do is we have a way to ask. We have this object, And then we need a way to ask if this is something. I guess. I mean, we can add like a little bit of a cheat for ourselves because we know it's a JS object, and we can go in JSObject.h and we can add one little helper here. I don't want to add too much. I don't want to add web-specific stuff in libjs directly as much as we can avoid it, but we can have like one little thing here. We can have like an is a web wrapper thing, and this is not JS specific but rather web specific, but I feel like that's a small little thing that we can do that, but let's try to keep them separate otherwise. Just because it's nice to keep these two concerns separated. JavaScript and the web in your implementation at least. So now that we know that something is a web wrapper, which of course we'll have to actually override somewhere. So here in wrapper, which inherits from JSObject, we'll say that virtual bool is web wrapper, return true. So this is a final override. So then I guess we could have just a whole bunch of things on here, for example. That would be one way of doing it. We could do something like this. I don't know, this doesn't feel like a very scalable solution because we'll have to end up like adding one for every different type of thing. So I think I'm going to do this now, but this is not going to work in the long run to do it this way. But let's do it this way for now. It's node wrapper, document wrapper. And how do we make those things? Wrapper generator. I mean, he can just crap out an override for that. So when we make a header, we say builder append is. Oh no, wait, hold on. Is foo wrapper name. It's going to be string format is wrapper class dot characters, and then we'll snake name the heck out of it, and then virtual bool is foo wrapper name const final return true. How about that? Oh, I guess it's doing libjs first. Man, I'm so glad that I'm sitting down to engage with this. I've been postponing this task forever because it's like I didn't want to do like a crappy parser at first. I just like kept thinking, oh, I'm gonna do a nice parser from the start. Then I realized that this was what kept me like postponing dealing with it. So now today I just figured let's just make a crappy parser and get started on generating the code, because generating the code is the interesting part anyway. And oh shit. snake case mistake there, because it doesn't deal with the title case. So wrapper gen, camel name. So it's actually a title name, if we are gonna support that as well. So bool first true, first false. If not first, ninja. Oops, node wrap. Do not save. Yeah, that's better. But yeah, right, of course impl from has to actually look at that thing. So wrapper generator, impl from. So instead of doing that check, we'll have to do a so if it's a web wrapper, if it's not a web wrapper, or static cast wrapper this object where's that is foo wrapper name here? Protected within this context. Oopsie. I wanted those to be public. Okay. So, can we please call document first child? Yes, we can. How very cool. Wonder what his node name is. Node name. The first child is a doc type node. That's so cool. Let's call his first child. He doesn't have a first child. What about the next sibling of the first child? It's the HTML element. What about his next sibling? He doesn't have one. Wow, I could do this all day. Okay, that's so cool. We can actually call these attribute getters now. That is awesome. So yeah, so this is going to be a little bit of a hack, and then we'll have to think up something smarter later, but I don't want to get into that right now. libweb plus libjs a little bit. Add a naive way to check if a wrapper is a certain type. Instead of only checking the class name, we now generate an isFoo virtual in the wrapper generator. It's currently something we override on bindings wrapper, which is not really scalable. Longer term, we'll need to think up something smarter for verifying that one wrapper inherits or is shares Wrapper inherits, or is another type of wrapper. Yeah, but for now, we just want to make it work, so that's pretty cool. Maybe let's add some more APIs, just because why not? Because it's so easy now. Parent node should be pretty easy. Do we have that in node.h? Parent node, we don't have it, but we can totally add it. Or wait, maybe tree node already has this parent. No, it only has parent, but not parent node. So let's add it. Just put it right here. Node, parent node. We can even add a const variant for those of you who are into that sort of thing. And parent element. What is the parent element? It's if you have a parent of a different type, then the parent element is null. Why don't we offer that as well then? Wait. Let's write this properly. So if no parent, return null putter, or not parent, not is element parent. Yeah. Does that make sense? No, it doesn't. Okay, static cast. I don't remember how exactly this is supposed to look here, but something like this. Oh wait, but we don't see the element type here, obviously, so we have to wait until we can see it. So these need to go after element has been declared. Or we can just put them in the ZPP file and not be so silly because they have no reason to go in the header. We'll just put them here. So how do we write parent element? If no parent or not is element parent. Yes, beautiful. So then let's see, let me edit my creator thing. CPP or name, because I want to see IDL files in here as well. Node.idl. Boom. Read-only attribute node, parent node, and also possibly element. So now it should start to become a lot easier to add more stuff like this. And I think this is going to be so cool. Because I've been like holding back from adding all kinds of stuff to JavaScript, to the web JavaScript stuff, just because it's so tedious to write these wrapper files. And obviously now all I had to do this one was like one line of code, and this was like 3 lines. But I did a const and non-const version. But still, it's like trivial compared to how much stuff you had to do before. So let's see, document parent node. It's null. That's exactly what I would expect. What about his first child's parent node? It's probably the document. Node name? Yeah, we should make this thing show what kind of thing it is. That is so cool. And parent element should actually fail here. It does, because document is not an element. But what about document's first child's next sibling? Dot first child should be the HTML element. Yes, it is. Cool. Very, very cool. So commit libweb. Add node parent node and node. Oh wait. Parent element. Atomic BI. Super cool. Ah, man. All right. So I am pretty happy with this, I have to say. So I think this will be the end of today's video. If you made it this far, then I thank you for watching and for hanging out. While we finally generate some code from a very simplified IDL format, we'll definitely improve this over time, but right now I am really happy with what we ended up with. So query selector all, get that, and look at that, all of these guys, all of the entries, they all have all of these next sibling things. Oh, it's so slow. Wow. This thing needs a little bit of performance work, it seems. Anyway, yeah, this was really nice to get it done. Some pretty hackish stuff happening, obviously, but sometimes, especially when it comes to code generators, it's so much better to write a crappy code generator that writes good code than it is to write a beautiful code generator that writes crappy code, or even worse, in my case, not writing a code generator because you wanted to wait until you would do it perfectly. I'm really happy that we just got one done. At least got one started, let's say. So, enough rambling. Thank you for hanging out, and I will see you next time. Bye.